All right, guys, here's the last piece of what we were talking about today in class, particle motion. I put this up on the board for you guys to take a look at before I start going over. I did make some changes, so make sure you note the changes before you start doing the problem in your notes. All right, it says a particle moves along the x-axis according to the position function x of t equals 1/3 t cubed minus 4t squared plus 12t plus 1, where t is between 0 and 10. We're going to do three things. We're going to find the intervals where the particle moves to the right. We're going to find the total distance traveled from 0 to 10, and then the total displacement of the particle. So let's start off with where it moves to the right. What we got to remember is that this is a position function. So if we were to take the derivative of that, that gives us a velocity function. So let's go ahead and take the derivative of this and get a velocity function. So our function is x of t equals 1/3 t cubed minus 4t squared plus 12t plus 1. And if we take the derivative, which is our velocity, we would end up getting t squared minus 8t plus 12. Well, here's the thing. When the velocity is equal to 0, that is where the particle would be stopping for a second and potentially changing directions. So let's figure out our critical numbers by setting this equal to 0 and solving. So we factor this out. This would be t minus 6 and t minus 2, which gives us t equals 6 and t equals 2. These are the places where the particle is going to pause for a second and either move to the left or the right. The other thing we got to realize is that velocity is a vector. And vectors, when they are positive, they are going to the right. When they're negative, they're going to the left when we're talking about horizontal plane. The other thing we can look at is, we talked about last chapter that when a derivative is positive, the function is increasing. Well, going to the right on the x-axis would be increasing. If it was negative, it would be decreasing, and that would be going to the left. So we're going to take these values and set up our table that we did back in chapter 3. So we're going to plug in 0 to 2, 2 to 6, 6 to 10, since that's the interval that we're working with. We're going to plug it into our velocity function, and that will tell us what our position is doing. Make that x of t. So let's put 1 in here. If I put 1 in here, I get a negative, and I get another negative, which gives me a positive. Positive tells me x is going to increase, which means I'm going to the right. If I put in something between 2 and 6, let's say 3, that's going to give me a negative. That's going to give me a positive. This gives me a negative. That tells me x is decreasing, which means I'm going to the left. And between 6 and 10, let's put in 8, positive and positive, which gives us a positive. It's increasing again, which means it's going back to the right. Okay, so our intervals where this is moving to the right are going to be 0 to 2, union 6 to 10. If we wanted to know where it was moving to the left, we would use 2 to 6. So there's the first part. Now let's take a look at total distance. We're going to go back to those critical numbers. Okay, so let's look at a number line here. We're moving along the x-axis from 0 to 10. Oh, that's time. Correct me. All right, let's use those critical numbers. All right, we're using 2 and 6. Like I said, those are the places where the velocity was 0, so that's where it stops and turns around. Well, what we need to find the total distance is how far did it travel during those times. So I need to figure out what value x of 0 is, what value x of 2 is, what value x of 6 is, and what value x of 10 is. And then once I find those values, I need to figure out the difference between them and add them all up. So bear with me, these numbers get a little large. If I put 0 in, I get 1. That shouldn't be too hard. But 2 in, I'm going to end up getting 1/3 times 2 cubed minus 4 times 2 squared plus 12 times 2 plus 1. All right, well, let's simplify that out. This gives me 8/3 minus 16. Well, 16 over 1 could become 48/3. This is 24. So 24 times 3 is going to give us 72/3 plus 1 is 3/3. All right, we get negative 40 plus 75 is going to give us 35/3. So from 0 to 2, for time, it traveled from 1 to 35/3. Now let's find out x of 6. So if I put 6 in there, I get 6 cubed is 216 over 3 minus 4 times 36 plus 12 times 6 plus 1. All right, so we got 26/3 minus, this is 144 plus 12 times 6 is 72 plus 1. This is actually 72 as well. So here, this actually just gives us 1. And x of 10 x of 10 is going to give us 10 cubed is 1,000 over 3 minus 400 plus 120 plus 1. That would be 1,000 over 3 minus 1,200 over 3 plus 360 over 3 plus 3 over 3. This gives us negative 200, gives us 160, so 163 over 3. Okay, so all kinds of fun numbers here. Total distance. So if we think about it, it started here when time was 0, it started at 1. It moved to the right until it got to 35 over 3. Then it moved back to the left until it got back to 1. And then went back to the right until a time of 10, which it made it to 163 over 3. So we have 3 different distances we got to count. 1 to 35 over 3, which if we make this a 3 over 3, that would be 32 over 3. Another 32 over 3, plus we got to figure out the distance between here. This would be 160 over 3 if we take away that 3, because remember we're going from 1 to 163 over 3. All these together are going to give us our total distance. So that's 64. So this is going to be 224 over 3 for a total distance traveled. All right, so now we have our total distance. Our last question was displacement. Well, displacement is the difference between where you start and where you end. So displacement is the difference between starting and ending position, which if we started at 1 and we ended at 163 over 3, we just have to find that distance between them, which in this case would be 160 over 3, which was that last distance we found. That would be our total displacement. Okay, and that would be our particle motion problems. Now there's other variations to these problems, but that at least will get you started on the homework tonight. So work through those, Remember, use that velocity to figure out where it's going to the left and the right. And then once you find those critical numbers, you can use those to plug back into the original problem to figure out what positions they ended up being at those times and measure them all together to get your total distance, and then you can find your displacement. Okay?